My name is Seth, and I'm here with Elliott today to talk a little bit about a Blink program that we're calling Systems Design. So you've probably heard updates from a number of programs today, and this one is an attempt to sort of figure out, rather than tackling certain use cases or verticals in Blink, this is about the overall health of how we evolve the browser and continue adding features to it. So for an intro, Chrome is a bit like a system like this engine. It's got a bunch of interconnecting parts, and by now it's big enough that it's very hard for any one person to keep the whole system design in mind. And if you're working on adding a new feature or modifying the browser in some way, it can be a bit like trying to fit this small screw into the rest of the engine without modifying or breaking something that already exists. So a little more concretely, we spun up the systems design program to ensure that Chromium code base is architected in such a way that it's both easy to efficiently add high quality features or continue to evolve our implementation of the web platform. And not only do we want to make it easier to add new features, we want to be able to better refactor what's already in Chromium, and ultimately we want to be able to make it easier to evolve how Chromium works should we need to change to meet future demands or future use cases as the web ecosystem changes too. So again, that's still a little high level. So to put it a little bit differently, systems design is not necessarily about being a gatekeeper of Chromium's architecture. So it's not about reviewing every design, or it's not about signing off on every design doc that flies by, but it's about having a group that's specifically tasked with evangelizing, enabling, and sort of being a consultant for reaching a place where the code base is healthier and the process for adding changes to it and modifying it is much easier. So specifically, what does that mean? We still are kind of dancing around how this program actually does things. We came up with an acronym, or Elliott came up with an acronym called RISE. So we won't use the acronym that much because all these acronyms are hard to remember.
Acronym bingo.
Yeah, exactly. But it stands for 4 key parts of what this program sets out to do. So the first is research, which means that this group will be able to spend time specifically studying how other platform implementations work, seeing what's different about other implementations to Chrome, and producing the sorts of design documentations that the rest of the Blink contributors can use as just useful references when planning their own features. So it'll help to have somebody or a team whose one of their primary jobs is just to produce documents for knowledge spreading. The second part is to identify systems in the engine that can be that say overlap in functionality or could be improved by changing and potentially unifying their implementations. So in other words, as a contributor, if you're constantly looking at Chromium through the angle of your particular lens, the area that you're working on, you might not necessarily notice when one piece of the engine looks quite like another. So one of the jobs of the systems design program will be to sort of proactively try to identify these areas where closer collaboration between different teams or different contributors could result in a more generic or a more unified implementation. And paint and layout is an example that Elliott will talk more about later. The fourth thing is to simplify our implementation in the first place. So this isn't just about making it easier to add new features, but we want to get to a place where through servicification or frameworkification or a bunch of other efforts where we can just...
You put ification after your thing, it's trendy now.
Exactly. But we want to get to a place where we can do refactors and embark on projects that fundamentally make Chrome simpler and smaller as well. And finally, because so far, this program is just 2 people, and one of those people is PM. We have to make sure that we can enable everyone else to actually do the engineering and the hard work involved in making Chrome simpler.
Everybody here.
Exactly. And part of that can be through evangelism, through maintaining a global backlog of projects and helping with tracking the completion of tasks. But it can also be coming up with designs for more shared libraries, higher level frameworks, more documentation, and other ways to just sort of reduce the cost of bootstrapping new functionality in Chromium. So I'll quickly, I think I went through most of these things, but I'll quickly go through them again. So on the research side, comparative analyses are one thing that would really help get a sense of basically how best to move forward on certain aspects of Chrome. We have some ideas about how we could potentially study the history of Chromium contributions and existing processes to see where there are inefficiencies that could be, or to where there could be different ways that we could work that would better help implementing new things.
Yeah,
And
we want to answer questions like if you ask, how do we compare to Edge on X feature? Or did Safari do this differently? We should know those answers. And we should have that all documented. So as we make decisions, it feels like our decisions were deliberate. Like we chose to do that. We were informed and we did that on purpose.
Yeah, that's a good way to, definitely a good way to phrase it. And then also I think some amount of this is being able to come up with some metrics for how Chromium evolves over time, and to be able to answer the question, does it get easier to implement new features, and is it a healthier code base in the end? The identify part is something that I think will happen by keeping track of design docs that fly by and trying to have a better understanding of how things are changing in the large. It's about finding this overlap between projects that might be occurring and across 2 different teams or in 2 different parts of the code base. And ultimately, these things would guide, potentially refactoring things or providing some sort of generic components that can help handle some of the logic there. Simplification, a good example of this that, again, Elliott will talk more about later, was the BlinkOn soup project. And so you can imagine other sort of refactoring projects being kicked off under this umbrella. And being an advocate for the various methods that the various ideas we have about how to guide Chrome's architecture to a simpler one. And if we're not actually producing CLs, things we can do to help out are providing frameworks and libraries. Potentially hosting discussions with the right stakeholders. So sometimes even just getting people in the room is the right first step to figuring out how to solve some cross-cutting architectural issue. We've got plans to maintain a backlog of projects, and finally, some amount of the architecture that Chromium should move towards should be informed by how Chromium contributors are currently developing within Chrome, and also how external developers are developing in the web ecosystem. That's sort of a fuzzier part of this enablement.
Yeah, so like an example I met with another company recently, and they said, we rewrote Mojo, it's better. And I said, why didn't you tell us? As we're trying to open that channel, both internally and externally, because there's all these high quality contributors, like Opera contributed the compacting garbage collector, but there's lots of other companies that are doing amazing work, and they do it external to our code base because sometimes it's hard to understand our roadmap and the code base and what we're thinking. We want to open that up. We want to collaborate with everyone so that we can really enable that type of like groundbreaking change, but for everyone.
Exactly. No. So, so that was the high-level overview and probably the most hand-wavy part of this whole presentation. So I will now turn it over to Elliott, who is going to talk about a couple projects that either are already in existence or fit the model to embark on after the fact that sort of fit all under this systems design umbrella. So sweet. Yeah.
So the first thing I want to start with, everyone raise their hand if they've tried to make a change in Chromium and it seemed like way too hard. Okay, if your hand's not up right now, you're lying. Because like if you worked on this code base, it's like 10 million lines and it's like 20 years old and like it's like super painful. So I'm gonna go through a bunch of examples here, but like the big theme, the thing that we want is that, you know, in a year's time, maybe it takes longer than that. We should poll people in the room. We should be like, is it easier to work on Chromium now? And everyone should be like, yes, it is so much easier. Like it's more fun. It feels like we like work together and like we make decisions on purpose. So that's really where we're going here. So I'm going to start with servicification. So we take Chromium, we strap a jetpack to the back of it. And so servicification is this effort by which we take the enormous Chromium code base, those 10 million lines, and we break it apart into lots of little pieces. And that brings us things like stability. When the Bluetooth code might have a bug in it and crashes, today it actually crashes your entire browser because the Bluetooth code is running inside the same process that also happens to be running the Chrome UI and everything else. No, that's not the web platform side. That's the like part that actually talks to the operating system. So there's an effort that's building something called like a device service and says, let's move all the code over there. So you see this in a modern operating system. If your graphics driver crashes, the screen might flash at you, but all your programs don't restart. And that's the direction we want to go in. This also gets us awesome testability because you could actually bring up a low-level component like the file system service, and you could write tests against it without having to bring up the entire Chrome code base and then to write stuff at the like far end of the web platform to test some feature. And this should really improve our velocity by bringing like much better ownership into the code base. So I have a diagram here. This is servicification. Servicification says Chrome is not a Chrome process and a render process. It is not Chrome in the web. It is just a bunch of services, and they all happen to speak Mojo. And in this world, there's things that there might be multiple instances of. That could be like the Chrome UI. That could be the clock at the bottom of Chrome OS. It could be a web tab. It could be PDFium. It could be any one of these things. And then there's this big collection of services. And that's everything from like the notification system to sync. Sometimes these things will start and stop. We've even heard developer feedback externally that Chrome seems very large for the amount of resources it consumes. And that's because everything's always running all the time. So this is going on right now. We're working on refactoring the whole code base. You'll see there's like a services directory. There's all kinds of changes going into this. But this should also be really empowering because it allows you to have some piece of code that's on demand, that can be started and stopped, and does not directly impact the stability of the primary product.
Sounds like if we would be more buzzword compliant if we renamed it to microservices.
That's true. We could name
Like
it microservice.
we made a mistake there. Yeah, I don't know.
Maybe L5, L6, because L4 is the microkernel that already exists. So yeah, one I've talked about before is BlinkOn soup. BlinkOn soup said the code base is made of many layers and none of them make any sense. So it took those and tried to make sense of the layers. And that's allowed us to actually move a lot faster. We've deleted almost all of content renderer. We've vastly simplified the code base. And we've been quickly moving in this direction where we want to get rid of lots of the abstractions inside content. We want to talk directly to the browser from inside Blink. We want to have a good abstraction layer around features like autofill. And we want to have sensible layering around things like glue around operating system features. And the other thing here to note is that this process is actually turning Blink into just another service in that servicification ecosystem. Today, the render process, what is the web platform, is sort of like a special thing. But it really doesn't have to be. It's just another service that runs inside a sandbox. And there's lots of other services that run inside sandboxes, like inside the Chrome system. So for example, there's the V8 proxy resolver. Maybe you didn't know this, but when you go to a website, there is a feature by which your network can supply a tiny JavaScript file that contains a bunch of regexes that filters your network request and maybe redirects it to a different location. Perhaps your corp network likes to do that. If you work for Google, the answer is yes. So the next thing is frameworkification. This is the process by which we take Blink and we say, Blink has invented a lot of awesome technology. For example, OilPan and TraceWrapper. We have all kinds of really awesome abstractions around display lists and other various features. And we say, what if we could just reuse those? Frequently, someone comes to us and says, I'm building a thing that uses the web, but a little bit of it. For example, maybe it is the clock at the bottom of your operating system. And today, that stuff is all built from scratch separately. But it'd be awesome if we could figure out how to combine our efforts, reuse the incredible amount of engineering talent that is in this room and the overflow room, to push the entire system forward instead of just the web platform. And so this will take the web platform and break it into these large pieces. They're like underpinnings of it. That's everything from a high quality binding system that combines OilPan and JavaScript and the V8 code to a loading framework that takes the vast and complicated interfaces we have today and tries to make them look more like the web. The web developer calls fetch, and they know that it does the right thing. A Chrome developer calls one of 500 C++ functions and calls Kuhei when it doesn't. So we really need to get there. Like that's what's going to empower us, is when we can bring that level of confidence in our libraries to the code that we write to. So another effort that we've been working on is the NEXTGEN engine. There's a talk about this at some point tomorrow. The NEXTGEN engine says our rendering engine is essentially KHTML evolved over like 20 years. And maybe we should rethink some of the design. In particular, we'd really like to enable more complex layout models. That's things like fragmentation, use cases that were designed for CSS regions, complicated multi-column. We'd also like to enable complicated paint effects like shadows and things, but have them be really fast. And that's going to require us to rethink how all the parts of the engine talk to each other. And so we do that by taking the idea of how the DARM and style work and rethinking the output of them, building a new system of display lists and property trees, rethinking where we compute composited layers, and finally how we paint. And my diagram is super hand-wavy. The presentation tomorrow will contain like detailed diagrams without all the missing pieces I omitted. Just squeeze it on one slide. But the thing that's going to come from this is that today, as an example, when you put position relative on a lot of elements on your page, your entire page gets really slow. And so we've been working with them to rethink how the engine works from one end all the way to the other. So when someone looks at the rendering engine and they say, why does this work the way it does? It was deliberate. We say we did that on purpose. From end to end, we thought about how the whole system worked. It's not 15 years of like evolution and engineers all over the world just pouring code into this awesome code base. Mm-hmm. And another one that's come up recently is speed architecture. There's multiple different systems that are collecting speed information. There's tracing, there's perf monitor, there's perf timeline, there's several others. And they're sort of all over the place. And what we've been working to do is centralize all of those into a single system that collects perf metrics all over the code base, and then can answer such questions as, how long did it take between A and B event to occur? So you might wonder, given a key press, how long did the next paint take? Today, that's extremely manual. You'd run plumbing all over the code base. You'd put timing and all kinds of things. You might add new IPCs. Instead, what you'd like is the same simplicity a web developer has, where they have some performance timeline, it has paint events and some key events, and they delta between them. And as our team has grown and our thirst for knowledge has grown, the number of metrics we report has also exploded. And this is about simplifying that and making it so that it's easy for everyone in this room to learn the metric they want to learn, but also not impose that kind of burden on the code base. And it's going to be awesome because not only can we use that knowledge to report metrics as in this diagram, but once we have that set of knowledge, we can actually use it to feed back into the system as policy. And that means things like prioritizing the foreground tab, changing the way the browser works when you're loading web pages versus when you're interacting with them, and also prioritizing content you go to frequently versus content you've never been to before. And that's going to be awesome. So this is like super primordial. Doesn't even exist yet, but is so awesome that you should be excited. And that's sort of the direction we're going, is trying to think about the entire system and these big cross-cutting concerns and rationalize all of them, and then get everyone in this room empowered to make changes at that scale.
Sure. Yeah. So I think I think the overarching theme between among all of those examples is that right now there's no one person sort of driving all of them, and it's sort of, they touch on so many parts of Chromium that requires just a bit of organization to make sure that the right people are in the right room and that we're prioritizing among them correctly. So that's really all the systems design program does, is just to sort of make sure the pieces align to solve problems such as the ones we just covered. So if you're interested, if you have ideas for how we can do that well, and if you're interested to learn more, I put a link to a document which is a 2 pages introduction, covers a lot of the content in the slides, and we will kick off further discussions and meetings by sending an update to the platform architecture dev list. So definitely join that and follow there for updates. And I'm curious to hear, we're both curious to hear from everybody if this sounds like it's a useful program and how we can make sure it's useful going forward.
Yeah. How we can get everyone in this room to feel like changing Chrome is easy.
Yeah.
Awesome.
Great.
Thank you.
Thank you.